Jessie.
Thank you very much. My screen. And let's make sure that we have all of our presenters here. I saw Michael, I saw Sylvia, Catherine's there. Is Kate here?
Yes, I'm here.
Good. Well, welcome everybody to PechaKucha 2020. It sounds much longer than that, but in Japanese you say PechaKucha. This system of presenting was invented by an Englishman, friend of mine, architect who lived in Japan, and he started this up with a group of artists and architects who had a tendency to talk too long as a way to keep them brief and be able to look at lots of people's work all in one evening. And it's really taken off as a system. It's used all over the world for really cool events, kind of TEDx style. And we thought it would be a great way to have presentations from people who may not be comfortable presenting for a full half hour, but had something really cool and interesting to share. So today we have some people who are quite confident with their presenting, and they're going to set it up for us, and hopefully we can turn this into an annual event. I've called this still the GIS Day event 2020-ish, because we're still calling this our GIS Day event, even if it's been slightly pushed forward. The way it'll work is I will present each speaker, and then I will start the slides running on the automatic timer, and they will just talk through their 20 seconds for each slide, and they may discover that they have a little bit more to say on some and then others, but the slides will keep on going. So our first presenter is Kate, who is going first because she's going to have to slip away before the end. She's got another presentation to move to. She's from the University of Houston, and she's going to talk about how they've really been upgrading the process of using GIS in their libraries and the initiatives that they've been taking on board at UHCL. Okay, Kate, so if you're ready, you can turn your microphone on and I will start your first slide.
Okay, and I just wanted to let you know we're seeing the presenter view instead of the full presentation.
Oh, so I need to switch on that one, right? No. Oh dear, how do I make this happen? See display settings. There we go. That's better.
Okay.
There you
go. Okay, and I'm seeing it a little bit cut off. Is that everybody's?
I'm not. Is anyone else seeing it cut off?
Yeah.
Yes. Yeah. Mm-hmm. It's cut off on the sides.
Mm-hmm. On the sides. Wonder how we fix that. I don't really know why it's cut off on the sides. Let me try one more time. Showing the whole thing, or is this the presenter view again?
It's the same. It's showing the presenter view.
And this time it's not allowing me to even end it. This has not happened to me before. I do this every week in my class.
I wonder if you uncheck the box for presenter. Oh, that looks
right? Good. Yeah, that looks
perfect. Okay, excellent. Okay. All right, Kate, let's go.
Okay. All right. Thanks so much, Jessie. And hi, everyone. Yeah, my name is Kate McNally Carter. I'm a research and instruction librarian and geography and GIS subject liaison. So I'm going to talk a little bit first about the university itself. So for those not familiar with us, we're located in the southeastern quadrant of the Houston area, and we're on 524 acres of natural green space and a wildlife preserve. Our enrollment is around 9,000 undergraduate and graduate students. We also have a campus in Pearland, as well as Texas Medical Center campus in downtown Houston. UHCL was founded in 1974, and it was originally established for the NASA community in Clear Lake. And we still have pretty close partnerships with Johnson Space Center and through our administration, as well as in our library's archives. So at UHCL, historically, Geographic Information Systems has been a key component of our geography program, which is housed in our College of Human Sciences and Humanities. It's also a crucial tool used for research projects at the Environmental Institute of Houston, which is also located at UHCL. So recently, our biggest goal with our GIS services has been to promote them and encourage their use across disciplines. So many members of our community associate GIS exclusively with the geography program or with the environmental science program or the Environmental Institute of Houston research projects. But as many of us know, GIS has many cross-disciplinary applications. So what we are striving to do is to expand our community's concept of GIS and demonstrate how it can be useful in various fields of study, including public health, criminology, education, and so on. So we believe that the library plays a vital role in this. So because the library, it serves as a neutral and centrally located space for GIS services to be hosted, which takes it outside those traditional academic departments, which tend to limit people's perceptions across campus of GIS applicability in their fields. We can also serve as intermediaries between users and the software, and we can help with locating data and other resources. So to help accomplish this mission, the GIS implementation team worked over the late spring and summer last year to upgrade UHCL's Esri ArcGIS online subscription. For over 15 years, this subscription was administered centrally through the University of Houston system, which limited our ability to leverage the software to its full potential. So in addition to acquiring our own Esri subscription, the team established an ArcGIS enterprise-based deployment, which enabled the hosting of UHCL closed data and specialized server software. They also configured the ArcGIS Online and ArcGIS Enterprise single sign-on, which has enabled all UHCL faculty, students, faculty, and staff to gain access to the suite of mapping tools, training, and so on that Esri has to offer. So this has been a huge step towards increasing our community's access to GIS software and visibility of our software. And it was made possible by a team of faculty, information technology staff, and other administrators who invested time and resources toward accomplishing this goal. So once we had ArcGIS Online configured, I collaborated with the Geography Program Director, Dr. Jeff Lash, as well as another one of our environmental science faculty, Dr. Mark McGresh, to update the library guide for GIS resources and services. So this is an image of what our previous LibGuide, which used tab navigation, and it was a little bit less intuitive for folks who were not as familiar with GIS. And so here's our new and improved LibGuide that we launched this summer, and it uses side navigation, which aligns a little bit more closely to our university website and is more organized. So this LibGuide now serves as the main landing page, or one of the main landing pages for GIS at the university, and it functions as a central hub for GIS resources, data, and services. We also have ArcGIS software installed on campus computers for our campus community as well. And our technology department has also created a remote access dashboard rather, that makes it easy for users to connect to a campus computer. So classes in GIS are offered through the UHCL geography program as well as through the environmental science program. We also offer a minor in GIS. Another new development of the LibGuide that we added with our new improvement was that we provided resources as well for faculty who are outside those departments who want to incorporate GIS into their department or their classes. The Environmental Institute of Houston also provides data collection services for the UHCL community. So they provide assistance with locating data sets, processing GIS data, and geospatial analytics. And they also provide technology for collecting spatial and positioning data with UAS, GPS, and other survey equipment. So for GIS Day this past year, we planned a relatively modest agenda to begin generating some exposure and excitement for GIS resources at UHCL. So for one of our events, Dr. Jeff Lash officially launched a beta version of an interactive UHCL base map that he worked on with his students, and this has served as a springboard for other projects. Next, Dr. Jeff Lash also created a video series specifically, and I think that it stopped. Either that or this 20 seconds didn't take very much, or is taking a long time. Okay, now we go. All right, so next, Dr. Jeff Lash also created a video series specifically for the UHCL community that will help our students, faculty, and staff get started with GIS. So the hope is that these short 5 to 10 minutes videos will encourage more people to use the resources, and they're hosted on the library's YouTube channel, which is also very exciting. And finally, Jeff and I hosted a student success panel discussion, which featured several UHCL alumni who talked about how they're using GIS in a wide variety of professions, including private industry and local government agencies. They also gave some great advice for current students who are interested in pursuing careers in GIS. So what are our future plans? Well, we hope to continue expanding our audience of GIS users by demonstrating and promoting interdisciplinary applications. We'd like to expand our data services and also begin offering workshops that can help introduce GIS concepts and software. And also, I'd like to develop my own expertise to help provide more research consultations in this area. Other future projects that Dr. Lash is also leading include the development of a campus room finder app, which will be a tool that can help manage building spaces across campus. And this in turn will lead to the development of other research-related tools and apps. We're also looking to collaborate further on more videos and other projects. So that's all I have. I just want to give a quick shout out to Dr. Lash, who has been instrumental in leading the UHCL GIS team and making all of this possible. And I also want to mention Dr. Evelyn Morales, who is our Associate VP for Strategic Information Initiatives and Technology. And she has helped make this initiative a priority at UHCL. So that's it.
Well done, Kate.
It went by so fast.
You did a great job. Thank you so much. You are our first ever PechaKucha presenter, and we really enjoyed your presentation. That was perfect. So now everyone can see what it was about. It goes pretty fast, but she fit a lot in. There's actually time to tell a lot in 20 slides in 20 seconds. We got a really good idea of your initiative. It was really exciting. So Michael. Everybody knows Michael. I don't really need to present him and his work, but he's going to tell us a little about their GeoBlacklight work and the geodata portal at UT Austin. So, Michael, I will jump right in, and you are on.
All right, thank you, everyone. Hi, I'm Michael Shensky. I am the GIS and Geospatial Data Coordinator at UT Austin, and yeah, you might know me from my role with the TDL GIS Interest Group. I'm going to be talking to you today about our project idea for coming up with an integration between the Texas Data Repository and our Texas Geodata Portal. So to give you a quick overview of some of the services we offer here at UT Austin that are related to GIS and geospatial data, we have GIS LibGuides. We offer research consultations that are now being conducted via Zoom. So anybody doing geospatial research can meet with me for help with their work. We have GIS focused workshops that we lead each semester. We also have a Texas Geodata portal that I'll be telling you more about. So the idea behind this project is that UT is using the Texas Data Repository to allow researchers to upload and publish data sets to that repository for long-term access and to generate DOIs for their data sets. And we want to figure out if there's a way to get geospatial data that goes into TDR into our geodata portal to make it more searchable and accessible. The inspiration for this comes from Geodesy. This was a Canadian project being led by the University of British Columbia. They basically have already proven that this is technically possible, but they were using a Java-based approach. Whereas everything that we're doing to manage our portal workflows is done with Python. And so we are interested in seeing if we could do something similar using a technology that's a better fit for our infrastructure. This is our Texas Geodata portal. It launched in November of 2019, so it's been out for a little over a year now, and this is what we're using to currently share geospatial data from our university libraries collections, including scan maps as well as vector data sets with the broader campus community and the public. All of our data sets are publicly shared. This is what it looks like if you do a search for geospatial data sets from UT. You can see that we have currently about 700, and if you click on any one of those results that comes up from our UT datasets, you see an item description page that contains a geospatial preview of the data coming from a GIS server, and then below that, the metadata that we have for that data set. This Texas Geodata Portal runs on GeoBlacklight. So this is an open source technology that was created with Ruby on Rails that is designed to give you that web interface for geospatial data, and also it integrates with the backend that uses a Solar index to store metadata. So basically it's a search interface for geospatial metadata. The GeoBlacklight metadata schema is what we need to get metadata into in order for it to be searchable through that web interface. So it's a very simplified geospatial metadata format. And so basically we just need to condense our metadata down to these essential elements in order for it to be searchable through our Texas Geodata Portal interface. This is what that GeoBlacklight schema metadata actually looks like in practice for one of our data sets. You can see it's JSON or JavaScript object notation format metadata. And so what we need to do is find a way to get our metadata that's in other formats into this GeoBlacklight schema metadata format, into JSON. And so we've needed to automate that process. Once we get that data into that GeoBlacklight metadata schema format, we then need to load it into a Solar index. So Solar is a search platform for basically getting all of your information in JSON into a single place where it can be searched and retrieved really quickly. And so this is what our GeoBlacklight instance is hitting on the back end in order to search for metadata records for geospatial data sets. Now, what we'd like to do is integrate that Texas Geodata Portal with the Texas Data Repository, or TDR. So this is a TDL hosted repository that many TDL member institutions use for allowing researchers to upload and publish their geospatial data for long-term preservation and access. This is what that Texas Data Repository looks like if we pull up a particular geospatial data set. So this is a geospatial data set uploaded by one of our UT researchers. And so the geospatial data that exists in TDR can be uploaded in a variety of different formats. There's not really a lot of control over what researchers need to do before sharing their data currently. And so we need to find a way to detect geospatial data that might be in there and the variety of forms that might exist in. And so what we have attempted to do so far is use the Dataverse API. So Dataverse is the underlying technology that supports the Texas Data Repository, to use their API to query information about data sets in there to determine if they're geospatial or not. And so we've written a Python script that goes through this process, and it tries to figure out if all of the data sets that are currently in there that have been uploaded by UT researchers have geospatial characteristics. Do they have longitude and latitude or other location information? And if so, we can then automate the downloading of those data sets and the associated metadata for processing. And so this step shows what is produced by that Python script, where basically anything that it detects as geospatial, it downloads and then organizes in this set of directories. And once that data is downloaded, then we can go through further processing steps to try and get it into a standard format. So right now we're experimenting with getting it all into the shapefile format, and then publishing that data as a feature service to our GIS server, which we're using ArcGIS server as the software to support that. And so we've had success so far getting that to happen. So the script has successfully found CSVs that contain geospatial data and converted them to shapefile, then published them as a service. So our next step here is to really focus on the metadata. So we've successfully processed the data, or proven that we can at least process some of the geospatial data sets, but now we need to figure out how to extract metadata, which can exist in a variety of different forms in TDR at the dataset level or at the Dataverse level, extract that information and convert that into GeoBlacklight schema metadata. So what if we are able to do that next step successfully, then our goal would be using the combined data that we've extracted and the metadata that we've processed and then converted to the GeoBlacklight schema to put that into our Solar index and make that data then searchable through our Texas Geodata Portal. Once we're able to pull this off, and I think we will be able to, we definitely want to share our findings with others at TDL and other institutions that might be interested in doing something similar. So we are very interested in sharing in collaboration, and we're excited about the potential here. We're also interested in working with the Texas Advanced Computing Center to see if this might benefit them as well. And that's it. And that went really fast. If you have any questions or comments, that's my email address. Feel free to reach out. Yeah, it's a project we're pretty excited about, and glad to have the opportunity to tell you a little bit more about it today.
great. Michael, wow, that was a rush straight through tons of information in 3.5 minutes. Really useful to hear all of that. I'm excited about your Blacklight instance, the potential to collaborate between the universities with the shared data on that service. Sounds really interesting. Now I'm going to introduce my colleague, Sylvia Jones, who works with me at the SMU library and who is going to tell everybody something about the range of programs that are offered at SMU. Sylvia, are you ready?
Oh.
Hello?
Yes.
Yes. Okay.
Can you hear me?
Yes, we can hear you now.
Okay. Oh, yes, so my name is Sylvia Jones and I happen to be the Science and Engineering Librarian at SMU. And I'm just going to give you an overview of the different GIS services and programs that we have in the library. And I work very closely with Jessie, and I've been working with her now for about, 5 or so years. So in the library, we have a spatial literacy initiative, which is housed in the library. And this initiative provides a structure for GIS and mapping support at SMU. And it develops ways in which the growth of digital mapping and analysis in different departments at SMU can be supported and coordinated. So we have a staff that's comprised of Jessie, who's the director, who gives overall direction of the program. And I am the coordinator who provides, I'm responsible for the day-to-day running of the lab. And we have TAs who work in the GIS lab, they're the first stop for help for anyone who needs GIS assistance. So we work very closely with the GIS at SMU Research Cluster, which is a faculty research cluster. And the main connection is the director is a part of that research cluster. And the cluster helps us, the co-sponsor programs with the initiative on a regular basis. Okay. The faculty members there are the ones who I think recommended Jessie to be the director in the first place. So this image is the space that we have. It's in the main Fondren Library, right off the main research commons, and it's directly opposite the Starbucks. So it's a space that, even though it's used mainly by students and faculty working with GIS, it's also open to other members of SMU. So we have a web presence. This is a web map, a web page, which shows the different areas of focus that we have. So we provide teaching classes and we organize workshops for faculty and staff. We have created a listserv to share news about collaborations and news about our workshops. We have a dedicated space, and how we work at the beginning of each semester, we come together and talk about what our activities for that year would be. So we send this information out via listserv to other people so that they know what's gonna come up in that particular semester. Yes. So we have several events. We have local in-house events, and mostly we have like a welcome back event at the beginning of each semester, which is normally like an informal event where anyone who's interested in GIS can come in and get to know each other. And we talk about the plans for that particular semester. We normally have like food and drinks to attract more people. We also have a series that we call Here's How I Do GIS, where we have faculty members and graduate students. And in fact, anyone who works with GIS can come in and talk to us about the different ways that they do GIS on campus as part of their work or as part of their research. And again, this is it's open to anyone on a campus. We've been participating in a Mapathon since 2016, the Missing Maps program, where it's open to not just SMU community, it's also open to people outside of SMU, okay? And to these events, sometimes we have people just walk in and participate. Sometimes we have faculty members bringing their whole class to it. And sometimes we have people coming even with their families sometimes to join this Missing Map events. Again, we ask people who want to volunteer. We have a training session for those who can help other people who come in on those days to participate in these events. And we collaborate with other institutions. For example, I think 2 years ago, we didn't have a Mapathon at our school. We went to Mountain View College, they were celebrating GIS Day. So we were there. Some of our students and some of our TAs were there to help them celebrate their Mapathon. And so these are pictures of some of our TAs and some of our graduate students working with other people at that library at Mountain View College. And we encourage our students, whenever we have those outside activities, ask them to sign up if they want to be a part of it. Also, we have guest presenters who come in on a regular basis, really. One of the very important programs we have is the GIS Bootcamp, where we have Stace Maples, who's a GIS expert from Stanford. He comes in every year, and that's about a 3-day intensive program for GIS. This is open to not just SMU, but the community at large. We also participate with the digital humanities folks, and this is an image where we had a presenter from Baylor come in to do something on text, visualizing text locations. We had somebody from George Mason coming to talk about early American elections. So it's not just focused on just GIS. And then we have workshops where we invite experts from Esri who come in and offer workshops, sometimes for just specific classes, sometimes the general workshops for the whole campus as well. And this one I think was the last one that we had last semester, I believe this image shows, where we had over like 30 people participate. And in addition to all those guest presentations that we have, we offer workshops for classes. So the faculty members invite us, and this is a list of the different classes that we've gone in to provide instruction for sociology, history, real estate, civil engineering, business, etc. So we sent out an email, and this one was, we worked with the university research, where we had the civil engineering department doing something on infrastructure inequity last year. So we work with the research group, and we helped train, I think the other page is going to show, we train teachers on using the different GIS software. And part of that training entails that we show them all the different tools that they can use. And then they, in turn, were going to go back to the schools and teach the students how to use those different tools. And in the end, they're going to collaborate on doing a survey on infrastructure inequity in the Dallas area. And that result was going to fit into the civil engineering research project. So future plans are, we're going to continue to develop and coordinate workshops. We're going to continue to design the structure to integrate new geospatial courses. We're going to want to collaborate with the city of Dallas, maybe help get somebody to come up and help digitize the map collections. Want to continue to work with others. I know that's been very, very fast. I'm very sorry. Thank you.
You were fantastic, Sylvia. Thank you so much. It's really exciting to see you present all the work that has been going on. And in fact, you gave a quick introduction already to Joshua, who was in the last slide as a guest, and he is now going to be presenting himself about the work that he has been doing at Baylor. In particular, Joshua decided to narrow down in his presentation and tell us about the work that they've been doing this year with the COVID-19 dashboard that their program and their university has been.
Jesse, I misunderstood. I thought this was my first slide. Can you pause at this one for 20 seconds or so? Thank you. Sure. Like many universities, Baylor University maintains a COVID-19 dashboard. We have an internal dashboard that a select number of decision makers can access. This internal dashboard contains a map of off-campus positive cases. When the university needed to create these dashboards, who are they going to call? You got it, the library. As we have the data management and dashboarding expertise. All right, here's the public dashboard that you can find easily by searching for Baylor COVID dashboard. The screenshot was taken from January 7th, which is why the total number of active cases on the left in green is so low at 48. We have total active cases by status, with the blue line, that's the top one in the middle, representing students. Here's a screenshot from January 14th of the internal dashboard. You can see that all the tabs of content across the bottom, much more data and details. The active tab is the interactive map of off-campus cases. Apologies for the pixelation, but this is live and actual data, so I pixelated the red proportional circles. I know that these are supposed to be images, and I promise this is the only text-based slide. The entire automated process begins with contact tracers contacting students with positive cases and recording that in Excel, a Python script I wrote, then geocodes the addresses and calculates the distance to Baylor. The dashboard is run using Power BI. When a positive test result is returned, the contact tracing team contacts the person and leads them through a series of questionnaires and texts to help to identify who may have been in contact with these students or others. Whether the case is off or on campus, the data is entered into a spreadsheet in SharePoint. Here's a screenshot of the actual spreadsheet in SharePoint that the contact tracers use. This is just a small snippet of a very large sheet with a lot of content, including the full text of all correspondences between the contact tracers and students with a positive result. We can see 2 students in the screenshot who are on campus in Texana and Penland Hall. The remainder were off campus. We're going to zoom in on this a little bit more detail, but here we can see that lines 349 through 405 of a 550 line Python script represents the function that handles this off-campus mapping tab. This is one of 3 scripts that runs every hour, every day to process COVID data for both the internal and public dashboards. The geocoding, or the calculating the latitude longitude of each address, is accomplished using the publicly available geocoder Python library using the Bing Maps API to geocode against. This means the latitude, longitude, and precision are exactly where Bing Maps would place the address. The Bing key we use is a public key, which permits 2,500 free geocodes per day. Here is the little piece of the function that handles the geocoding. See how short and simple the code really is? If the address is not already in the database, you can see from the top line, if it's not a duplicate, the one line beginning with G equals, that's it. That handles the geocoding. If the precision or accuracy of the geocode is not high, it checks to make certain that they entered Waco in the location. To calculate the distance from each geocoded location, the publicly available GeoPy Python library is used. GeoPy is a popular and well-documented public Python mapping library that can not only calculate distances, but can also geocode, work with, and process vector points, lines, and polygons, as well as a lot of other things. Just beneath, so we're looking just beneath where we were before, the arrow is pointing to the one line that calculates the distance from Baylor to the latitude, longitude. That's returned from Bing. The distance is calculated from the centroid, or latitude, longitude of the center of campus to the latitude, longitude of the location. Here is a screenshot of the actual file that Python script outputs specifically for the off-campus mapping tab. The unique ID is there, the date, address, latitude, longitude. In this example, the precision is all high, and the distance that is calculated is in miles. Here's the same screenshot we looked at earlier. You can see the notes beneath the map, maybe you can, where it specifies that cases further than 2 miles out from Baylor, which we all know is from the Baylor center point, are excluded from the map. They are, however, included in the cases by date. If we ever did want to analyze locations further out, we have the data and can do so easily. Remember I said earlier that the expression language within Power BI is called DAX? That stands for Data Analysis Expressions and is related to the expression language used in Excel. What this is showing here is it's helping to normalize the locations, as not every contact tracer can enter the address the same. If it has this number and this name of the street, it's going to automatically assign the same lat long and apartment. Here's a screenshot of the Power BI interface that we use to build the interactive map. You can see under latitude, the latitude specified, longitude is specified. The proportional circles is based on the size of the cases. And then there were mouse over tooltips. Power BI also has, and we publish a dynamic hotspot view of these locations as well. This view has proven very useful to our decision makers to pinpoint troublesome parts in town with Baylor-related cases. In addition to the Python scripts that run every other hour on our dedicated server, the Power BI service updates multiple times per day. We can set it to update 8 times per day, but you can see we have it updating at 6, 9, noon, 3, 5, and 8 p.m. While the public dashboard is published as a public service, Power BI is integrated into Baylor's Active Service Directory. That means we can share dashboards with specific faculty or staff at Baylor. Unfortunately, our license does not include students. For student researchers wanting to create dashboards, we often encourage them to use Tableau instead of Power BI for that limitation. We also have a tab on the internal dashboard that maps residence hall or dorm. We track points to map students in isolation, students in quarantine, and students with reside in place orders. This data facilities maintains polygon shape files of every room on campus, and that's what we use to drive those point locations. Finally, to give you an idea of the complexity of managing COVID-19 data test results in a dashboard, here's a flow chart where you can see on the far left all of the data sources where test data comes from. The employee data's got to go through human resources, some have to go, and so there's a huge convoluted data management process to get to the dashboard. And wow, that was faster than I thought it was going to be.
That was a lot of information, Josh, that you gave us in 3 minutes. Really fascinating, the work you've been doing at Baylor. Thank you very much. And we're going to finish up with Kat, who just put it all together today to join our team and be part of the presentation. And she's going to tell us about the development of Mapathon as a way to bring people into GIS at UT. Are you ready to go, Kat?
Ready when you are. Hello, my name's Catherine Strickland, and I am not a GIS expert. So I wanted to appeal to the people that don't have GIS programs in place. Hosting a Mapathon is an easy way to engage students in GIS, introduce concepts, and get them involved in humanitarian projects. And I threw Zoom staff under the bus here because it also doesn't require special software, expertise, and programs. All you need is computer and internet. Mapathons are crowdsourcing editathons where participants edit buildings, road, hydrology, and other data on an existing map. They were started, OpenStreetMap is the basis for many Mapathons at this point. OpenStreetMap was started in 2004 as an open source online map focused on allowing users to add and share data. It's editable by anyone who creates an account, so people can go in and use local knowledge, contribute GIS traces, use aerial imagery, and even early on people would just trace field maps by hand and then translate that online. OSM's commitment to open data made it an invaluable tool for humanitarian relief. Enter 2010 when an earthquake struck Haiti. Crisis responders began planning their aid and couldn't find current and accurate maps. This is close to me because I work with a large scan map collection, and many people reached out to us for a 1967 map of Haiti. Enter the mappers in OpenStreetMap. In 48 hours, the image on the left here is what it looked like before. In 48 hours, crisis mappers and teams of mappers focusing on Haiti made a lush map of Haiti for humanitarian response. That was the catalyst for the humanitarian OpenStreetMap team, which basically took that idea and set up functions and made it easier for people to react to crisis. That has evolved into what Sylvia spoke about earlier, missing maps. Missing maps is rather than being reactive and responding to crisis, the concept here is to be proactive and just let's map vulnerable places, people, areas of the world. So that's kind of background, and I like to introduce this concept as layers. You know, OpenStreetMap is the base layer. Humanitarian OpenStreetMap team is kind of the mid layer, and Missing Maps is your entry point to creating a Mapathon. Wow, I get a chance to breathe. I was going quicker. With OpenStreetMaps, you can log on and you can learn. You'll see here, they talk about, they have a lot of tutorials on how to start mapping. They also have a lot of tools for organizing Mapathons. That involves, we're getting to the next slide. Sorry, y'all. So this is about learning the tutorials, and you can see there's 5 different links to tutorials for different levels of users. So you can engage beginners in mapping, and this can also engage people with some concept of GIS and who are already in geography programs or interested in mapping. The Mapathon checklist and how to host a Mapathon also has videos for you, checklist for planning, checklist for day of, which includes remembering extension cords, checking, you know, kind of basic things that often you don't think of, wedding planner type stuff for a Mapathon. And then you can track what's going on in an organized Mapathon through the leaderboard on Missing Map. And this is interesting. I'm going to get to some examples of Mapathons that I've been involved in. This is a great tool, one, if you're having a competition or if, you know, people just kind of are motivated by being competitive. When you start mapping, you're taking the OpenStreetMap tasking manager, and here you can sort different facets. So you can choose, if you're working with people who aren't regular mappers, you can choose beginner mappers. You can also filter for urgency or for areas of the world if there is an interest. This is a new one that beginner mappers, a present one that beginner mappers can use, and there's urgent needs. So this is a great one if you want, you know, actual to feel like you're humanitarian involvement. Basically, you're actually helping respond to a typhoon. Once you start, you choose a task and you start mapping, then you can edit you're editing OpenStreetMap within Task Manager. This is a new change. And you basically, they're looking for building and road data. So participants go in and say, oh yes, in satellite data, this is a building, I can tell, and they edit it. This is an example of an edit-a-thon that, an early one in 2016 with Leela Benson and the UT Liberal Arts Department. We planned a disaster relief Mapathon for Puerto Rico and Mexico. Puerto Rico had recently had a hurricane, and Mexico had an earthquake. So that got people involved who were interested in Mexico, Puerto Rico, and geography and GIS. So it was a good group of people helping each other. Another thing that I have done with Janny Fung of Austin, Texas, and Texas GIS Day is have monthly Mapathons. So we just have Mapathons at the libraries or sometimes at coffee shops. We bring snacks and people get together and hang out. More recently on Texas GIS Day 2020, we had a virtual Mapathon. There was also a competition. And this was great. Over 2,000 edits were made to OpenStreetMap, and students won prizes. Students and other participants won prizes. Since that was very quick, reach out to me if you want help. I'm happy to help people get these programs started. I think they're a great use of time and a great way to entry-level GIS. I did this before we had Michael, who has taken GIS, but I continue to do these for the humanitarian aspect. That does go fast. Thank you.
Thank you, Kat, Joshua, Sylvia, Mike, and Kate. You did a really great job, and isn't it fun? So that's the end of it. I'd be happy to answer any questions about the process, or I would be happy to moderate any questions that anybody else has to our speakers, if you'd like to ask them any further questions about their presentation. You could put your question in the chat if you'd like, or you could just turn your microphone on and speak. Most of the comments that I'm getting from the chat are just full of enthusiasm. Everybody was very excited by the presentations and really enjoyed it. I think that this short presentation really forces you to cram a lot of information into a short time, and we all learned so much in 45 minutes. So the challenge now is to ask all of you who are watching who didn't present to imagine over the next 8 months how you might be able to present a little story about something that you're doing at your university, and we can invite another 5 or 6 people to present just like this, 45 minutes of quick talks about other university libraries throughout Texas. So I think that we can tie it up now, and I'm going to ask
a question.
Somebody has a question. Yes?
Yeah, that's me. I think good job, everyone. I have one quick question for Josh. The GeoPy, I just wanted to know, is it a free service, or it has to be paid for?
Both of the libraries that I highlighted, the Geocoder and the GeoPy, are public open source Python libraries that if you're using Python, they have instructions. If you just search for them, they have instructions on how to install if you need to, and then how to import them into your scripts, and then how to use them. And so 100% open source and free.
Thank you. So the engine that it runs, because I know some of the APIs are all paid. You have to pay for them, for example, the Google and all those kind of things. So I understand that the code and all that will be open source, but if you want to really generate it, is that also open source? Or
talking about for the geocoding?
Yes, for it to work.
We use just because I'm familiar with the syntax, I usually use the geocoder library for the geocoding. That's what I use, the geocoder. And Bing, I think, is the most generous, and it permits 2,500 free geocodes per day. So as long as your project, as long as you're not going to exceed that, the Bing permits through you register for a free API key for Bing Maps. And once you get that key, and we walk students through that very easily, it takes less than 5 minutes. You get your key and you put that into place exactly where the documentation on the GeoCoder website shows you. They have very great examples. You copy and paste, and it will query Bing servers and return the latitude, longitude, precision, and a lot more data. Google
Alex
does as well. It's just less. They don't permit 2,500 per day. Sorry, Jesse.
That's all right. I was just going to say that Alex said that the recordings will be available. So Nathaniel, if you wanted to get some more detail from Joshua's slides, the recordings of all 5 presenters today will be available through Alex. And probably I should stop my screen sharing and pass it back to Alex, who can sum up for the end of the event.
Thanks, Jesse. I have nothing to add. It was fantastic, and I wanted to thank everybody for coming. And all the attendees will be getting a direct email from me with the recording once it's available. But after that, we'll be posting it to our YouTube channel, so it'll be for the larger group as well.
So thank you very much, everybody. I think we're about at the end of our time. It's 10 to 1. So thank you for joining us, and we look forward to seeing you at the next Texas Digital Libraries Group.